we will go ahead and get started. All right, so today we are going to be going through some problems from the back of chapter 6. These are going to be, let's try to zoom in a little bit. Chapter 6, and these are the problems. So there's questions, and then there's problems. So we're going to be starting with the problems. Better. Good. Okay, so the first problem that we are given is talking about, so number 1, this is where Zoe can decide between dividing her time between a wedding photographer which pays $27 an hour, or a fossil collector. Zoe lives a very interesting life. Fossil collector. And this pays both on the price of the fossils, right? So this depends price and the number of fossils that she finds. And so we're given some information about that. So we're told earnings aside, Zoe's actually pretty indifferent, right? So in terms of, you know, whether she does this one or that, she's indifferent. So either one's fine, and we're given some information that's going to help us make this decision, right? And so the information that we're given is the hours per day that she spends searching for fossils and the total fossils found per day. So given a nice chart of that information, and I will alternate so it's easy for us to read. If she spends 1 hour, she'll find 5. If she spends 2 hours, she'll find 9. If she spends 3 hours, she'll find 12. And if she spends 4 hours, she'll find 14. And lastly, if she spends, that was supposed to be blue, 5 hours, then she's going, wait, this is, sorry guys. 4, this should be purple down here. 5, and then 15. So we see that the kind of the marginal increase in the fossils, right? It starts off at 4, goes from 5 to 9, and then it goes down to 3, and then it goes down to 2, and then it goes down to 1. Okay? But that's not actually the real like information that we need to get out of this. So it's good for us to kind of note that and realize that we do have, you know, diminishing marginal returns to her finding fossils any given day, right? Which kind of makes sense. You know, you would find more of them in the first hour, and then, you know, it's like, you know, shopping at Marshall's or whatever. You know, if you get there late in the day, everything's all picked up. And so, you know, it makes sense that there'd be this diminishing marginal returns in terms of discovering the fossils. But what are we asked here, right? What's the actual question? So it says, compute, so this is the A part, I'll put it up here. It says, using the information, compute the lowest price Zoe would accept per fossil to justify, you know, her spending all her time collecting fossils rather than going out and being a wedding photographer, right? Which, as we know, pays 27 buckaroos an hour, okay? So how do we go about solving this? Well, it's actually, you know, it's actually kind of easy. it doesn't necessarily look easy at first, but it's actually kind of easy. What we're going to do is we are going to create another column to the right of this, and that column is going to tell me my minimum amount that I would take. Sorry. So this is going to be my, and we'll keep with the same thing. Oh, well, actually, we do need the marginal information. So I'm glad that we talked about it, because I misspoke. We do need to. So this is the additional number of fossils found. So this first one is going to be 5, right? So because we're not starting at 0, because we're starting at 1, we do actually have a value here, right? You know, because we go from 0 to 1, and we go from 0 fossils to 5 fossils, right? So this is going to be 5. And then I'm going to have 4 extra when I spend 2 hours. When I spend 3 hours, I'm going to have 3 extra. When I spend 4 hours, I'm going to have 2 extra. And when I spend 5 hours, I'm going to have only 1 extra, right? Okay, so now that we have that, now that we've calculated the marginal, the incremental, you know, revenue, but it's really the incremental fossils that she'll find, right? So we need to kind of figure out what is the price of these fossils that would make it so Zoe's better off, you know, out there collecting fossils in terms of she'd make more money, right? Again, Zoe is completely indifferent between the two. She just wants to make as much money. Neither one of these brings her more joy than the other one, right? Which is, you know, probably not realistic. You know, she probably has some preference for one or the other in real life, but for this example, we're just saying that she's completely indifferent, right? So what are we going to do? We're going to create another column. I promise this is the last column that we're going to create here, and this is going to tell us our lowest price per fossil. And so for this one, all we're going to be doing is we're taking that same $27, and then we're going to be dividing it by the incremental fossils, right? So this is going to be divided by 5, this is going to be divided by 4, this is going to be divided by 3, this is going to be divided by 2, and this is going to be divided by 1. And so then we're going to you know, calculate these amounts, right? And so I've already done that for us. So we end up getting 5.4, 6.75, 9.0, 13.5, and 27. And so if the price of fossils, and we're assuming that, you know, the price of fossils is kind of, you know, it's whole numbers, right? So we end up kind of, you know, just rounding this up to $6.00. We round this up to $7. You know, this is fine at $9. This we round up to $14, and this one is fine at $27, right? So, so as long as the price of fossils is less than 6, what is Zoe going to do? If the price of fossils is less than 6, what's that telling me? That's telling me that if Zoe goes out, and let's say that the price is 5, right? Zoe goes out and spends an hour, gets 5 fossils. Since the price is $5, that's going to be $25 that she made in that hour. Is that greater than the $27 she would have made as a wedding photographer? No, it's less than that. So that's what we're kind of getting at over here, right? We're figuring out what is the price at $5.4 per fossil. She's exactly indifferent between taking wedding photography for that hour and collecting fossils, right? But at $6, she is actually going to be, you know, better off spending her time collecting fossils, because 6 times 5 is 30, and that's more than the $27. And if the price of the fossils rises to, okay, so what that's saying is that she just wants to spend the first hour there, right? So if the price is like $6.50 for the fossils, we're going to stop at that first hour, and she's going to spend the rest of her time doing photography, right? Because if she were to keep on working, collecting fossils for that second hour, right? Let's zoom out a little bit now. And if the price was, $6 for that second hour, then how much is she going to make? She's going to make $6 times 4. She's going to make $24. So she would have been better off going out in the morning, collecting fossils for 1 hour, and then doing wedding photography stuff for the rest of the day. And so if the price rose to $7, then Zoe would be gathering fossils for 2 hours. She would supply 9 fossils per day. And so using this reasoning, we can get the price quantity supply relationship for fossils, which is what we got over here. So this is also, if we want to kind of talk about it in very jargony terms, which of course we do, economics. This is the price quantity supplied relationship for fossils. And if that, is a little confusing or whatever, don't worry about it. It's just kind of jargon. And really, it's the stepping stone for what we're going to do is we're going to take this information that we got here and we're going to plot them on a price and quantity graph, right? So we're gonna do an L. We're going to make the arrows. We're going to go LMNO P QRS, right? We always put the P to the left of the Q because of the alphabet in our mnemonics. We're going to make sure to title this. This is Zoe's fossil biz. We're going to have the, if we want, we can say this is the dollars per fossil. And then this quantity, right, this is just going to be our number of fossils. Get that all confused there. So how many fossils so we already did some of this, right? In terms of 1, 2, 3, 4, 5, 6. This is $6 here. So at $6, how many fossils is Zoe going to supply? At $6, Zoe's only going to supply 5, right? Because if she keeps on going for that extra hour, $6 times 4 is 24. That's not going to be as much money as if she had, gone and taken wedding photos for that hour, right? And so at $6, there's only going to be 5 fossils, 2, 3, 4, 5, that Zoe is actually providing. And so we go from a situation where there's no fossils being provided all the way up until 6, right? So if the price is 2, there's going to be 0. If the price is 4, there's going to be 0, right? So that's why it's just a up and down line here. And then as soon as we get to 6, it takes a step out to get to the 5 mark, right? So that at 6, we're going to be producing 5 fossils. And so then when we go up to $7, well, at $7, right, we know that Zoe is then going to be, put this back here, Zoe's then going to be doing 2 hours a day, right? And she's going to be getting 9 fossils. And so 9 fossils at $7, we can go ahead and reflect that on our graph here. 6, 7, 8, 9. And again, this goes right up and then over, right? Because it doesn't matter, like what happens if the price is $6.50 or something, right? If the price is $6.50, she's still only providing 5, right? Because $6.50 times 4 is what? 26? Yeah, 26. So 26 is less than 27. As a result, she's just going to go out for 1 hour and she's just going to provide 5 fossils, right? And so this is going to be 9 fossils. And we're just going to keep on doing this in terms of, at this new price, at 9, she's going to be providing 12. At 14, she's going to be providing 14. And at 27, she's going to be providing 50. And so we're just going to go ahead and we're reflecting this information, these total fossils per day and the lowest price per fossil on this XY graph, on this price and quantity graph. And so the next value, like I said, is going to be $9.12. $14. and 14. And then, of course, you know, $27. Oh, up here somewhere, right? $27. We could put a little break thing. And then same thing out here, the break. And then this is going to be 15. Oh, I guess we don't need a break over here. So 14, 15. No break. Sorry. So this is. And so, what does this thing look like, right? It's upward sloping. It's talking about how much, you know, an individual person would provide, right? So this thing looks like a supply curve. That's exactly what we are, you know, figuring out. This is Zoe's daily supply curve. Questions on that? Cool. All right, moving right along. So let's go to chapter 6, question 2. And again, all of this will be available on YouTube. So, you know, if you didn't get all of it, you'll be able to go back through and pause it on YouTube if you want to, you know, if you're taking notes at home or whatever the case may be, right? Okay, so chapter 6, number 2. And again, these are all problems. These are not the questions. Okay, so you got to go past the questions to the problem section, and then you will find these. All right, so we are told, let me go back to my book. You guys ever watch Hocus Pocus? One of my favorite movies. Ooh. Okay, so the supply curve for the only two firms in a competitive industry are given by, respectively, so okay, I should probably write some of this down. So supply curves for the only two firms in the industry are given by, so let's use red and green. We're going to have P equals 2 quantity of that first firm, right? And then we have our second firm is going to be P equals 2 plus Q2. Okay, so where Q1 is the output of firm 1, Q2 is the output of firm 2. So then we are asked, what is the market supply firm for this industry? What is market supply? So in a very similar way to how, you know, the demand curve, the market demand curve, the industry demand curve is nothing more than the horizontal summation, right? You know, we're just adding up all the individual demand curves. The same kind of thing is happening to the supply curves, right? Don't believe me? Well, I'll show you right now. So let's go ahead and do a price quantity graph here. Do another price quantity graph here. Try and give myself room for a third because I'm going to be adding these up. And then we're going to go ahead and just, you know, with the right colors, right? We'll graph out P equals 2 times Q1, right? So what is this? This is a line that's starting out at 0, 0. How do I know it's starting out at 0, 0? Because there's no plus anything. If I put 0 in for Q, I'm going to get 0 for the price. So that means it starts out at my origin right here, right? And then it's going to have a slope of 2, right? As my quantity increases by 1, my price is increasing by 2. So I have a rise of 2 for a particular run of 1. And I can just keep on doing that in order to graph this out. So hopefully there's no questions there. So just a couple points, right? This is 2, 1, this is 4, 2, this is 6, 3, this is 9, 4, oh wait, 8. I can count. All right, so that is our P equals 2Q1. That's the supply curve for our first industry, or sorry, our first firm, rather. And then we've got our second one, right? P equals 2 plus Q2. So do I start it at the origin here? No, right? Because I have something that's added to my Q whatever. And so since it's 2 plus Q, when I put 0 in for Q2, I actually get a price of 2, right? So I'm going to start at 0, 2. If we were using our coordinate system, right? 0, 2, because 0 refers to the x-axis, which is in this case the quantity, and 2 is referring to the y-axis, which in this case is the price. Okay? So then this just has a slope of 1, right? So if we don't have any kind of constant there, we always know that it's just a constant. It's just a 1 that's multiplied by it. So that means that it's a 1-for-1 slope. So for every 1 increase in my height, right, for every increase in my rise, there's going to be 1 increase in my run. And so it's just a very easy, it's going to be not as steep, or rather, it shouldn't be as steep. Probably doing a bad job of drawing it, but here is our P equals 2 plus Q2. So how do we get our market demand, right? Well, our market demand is just, we're adding these two things up. Just adding these two things up. So we're adding them up, and we end up with here. We're going to actually, that's why I'm using paper instead of the whiteboard like last time. So we're going to go ahead and always label price, quantity, and then we're literally just adding up the values, right? So at the price of 2, there was how many provided? There was 1 provided for this first firm, and there was 0 provided for the second firm, right? So at the price of 2, it's going to be 1. That's where our, well, again, always our market demand curve always starts at the origin, and then it's going to go up to this value of 1, 2. And then at this point, this second one's coming online, right? And so now when we're figuring out, well, what about at the price of, we'll just use 4, since that's where we have kind of the points here. At 4, there's going to be 2 provided by this bloke, right? And at 4 over here, there's going to be 2 provided by the second firm as well. And so 2 plus 2 is, you got it, 4. And so at 4, it's going to be 4. And so we see that there's a bit of a change in the slope once that second firm comes online. Now, once that second firm's online, they're both online, so the slope's not really going to change, but there's still going to be, there's still this adding behavior, right? And so if we go up to 6, so at 6, we had 3 demanded over here, right? At 6, there was 3 demanded. Where is it? 1, 2, 3, 4, 5, 6. And over here, 1, 2, 3, 4, 5, 6. That is 4. So we have 3 demanded here. We have 4 demanded here. So what's our I keep saying demanded. Supply. We have 3 supplied here at $6. We have 4 supplied here at $6. And so as a result, our total market supply is going to be 4 plus 3, 7. And then it really just keeps on going there. And so if we want, we also we can also have an algebraic solution. So in order for us, so this is kind of our graphical solution, right? But we're given these algebraic, equations. P equals 2 times Q1, P equals 2 plus Q2. So how would we figure out the market supply curve algebraically, right? Well, I'm glad that you asked. So the first thing that we're going to do is we're going to take this P equals 2Q. So this is, let's zoom in a little bit. This is algebraic. Let's see if I can spell this. Algebraically now. So we're going to take P equals 2 times Q1, and we're going to divide both sides by Q, right? So divide by 2. So we're going to divide both sides by 2, so we end up with P over 2 is equal to Q1. And for our other equation, right, we've got P equals 2 plus Q2. We're going to subtract 2 from both sides. And that's going to be P minus 2 is equal to Q2. And the next thing we're going to do is we're literally just going to add together the quantities, right? But we have to pay attention to the fact that there's a region where the quantities actually don't overlap, right? So for this for this region, right, when P is less than 2, the market demand is actually just going, or sorry, the market supply is actually just going to be firm 1 supply, right? That's going to be Q equals P, P over 2. Or, right, we also know that this just means P equals 2Q. But, so that's one of the ranges, right? So that, again, it's all part of this answer. So this is kind of the first part of the answer. Part 1. And then part 2 of it is when the price is greater than 2, right? So when the price is greater than 2, then now we're going to add Q1 plus Q2. So what's Q1 and what's Q2? Well, Q1 is P over 2, and Q2 is P minus 2. So we're literally just doing Q, the market, is equal to Q1 plus Q2 is equal to P over 2. That's what Q1 is, right? Plus P minus 2. And remember, parentheses. And so this reduces to 3/2 P minus 2. So because this is half a P, this is a full P. So this is 2 over 2. So 2 over 2 plus 1 over 2 is 3 over 2. The negative 2, the cheese stands alone, right? If we rewrite this in terms of P, let's do it right up here. So rewrite this in terms of P, we're going to end up with, so this is Q plus 2 is equal to 3/2 P, right? I'm just adding 2 to both sides. And then I'm going to multiply both sides by 2/3, right? Because that's going to annihilate that fraction right there. Now, be careful here. You're going to need to put parentheses around this. You're going to need to multiply the whole thing by 2/3. And then you can take that 2/3 and you can distribute it to the 2 items within that parentheses. So this P now is fine. He's all by himself, which is good. That's what we want. So we end up with P equals 2/3 distributed on Q is just 2/3 Q. And then 2/3 times 2 is, so this is 2 over 1. And so you just multiply the numerator and you multiply the denominators, right? So 2 times 2 is 4. Over 3 times 1 is 3. So our total market demand ends up being 2 actual equations, right? So remember, we got to keep in mind, this is only when the price is greater than $2, right? Because if the price is not greater than $2, we are just at this regular situation here, where the only firm in the business is firm 1. Questions on that? All right, moving right along. About halfway done with the class so far, so that's good. A couple of good questions. All right, this one should be fairly quick. This is chapter 6, number 3. So we're told the marginal cost of the first 6 air conditioners produced each day is less than 120. So let's write that down. The marginal cost of the first 6 air conditioners. Oh, sorry. That's the solution. Okay, let's go to the actual. Ignore that. All right, 3. A price-taking firm makes air conditioners, right? So we don't need to say that. That's a price-taking firm. The market price of a new air conditioner is 120 bucks. And we're given the firm's total cost information in the table below, right? So this is air cons per day, and this is our total cost. So what do we have? Get some new colors in here. We've got one air conditioner is 100 bucks total cost for that day. We've got two air conditioners is 150. We've got three air conditioners is 220. We've got four air conditioners at 310. We've got five air conditioners at 405. Up. Ignore that yellow, orange, whatever. We've got six air conditioners at, I keep doing that, 510. Right. And we have seven air conditioners at 650. And lastly, we've got eight air conditioners at 800. Okay. All right, now, what are we going to do? Well, first of all, what are we even asked, right? So we are asked how many air conditioners should they produce per day? And the question says, you know, given that their goal is to maximize profit, right? But I mean, that's always the goal, right? We want to maximize profit. So how do we maximize profit, right? So we're going to be using our golden rule, right? Where we're going to produce our quantity star, right? Is where our marginal revenue is greater than or equal to our marginal cost, right? This is our golden rule. By the end of this class, this should be, you know, embedded in our brains. All right, we're going to be using this so much. So let's. So in order to do that, right? Do we have our marginal revenue? Do we have our marginal cost? We don't have our marginal cost yet, right? We have a list of our total costs, you know, broken down incrementally, right? So keep in mind too, it's not always going to be, you know, 1, 2, 3, 4, 5. Sometimes it's going to jump, and so like this is actually a great moment to kind of warn you guys about that, right? So if it jumps from here, so let's come back to this for a second. I just really quickly. What if instead we had it was 1 and 100, and then it was 6 and, you know, 600? Then what would our marginal cost be, right? And so what I don't want you all to do is I don't want you all to kind of get in this habit of just taking this value, subtracting it from this value, and saying, oh, well, the marginal cost is 500. That's actually really incorrect, because our marginal cost is actually the change in the total cost per change in the quantity. And so if our quantity is increasing by 5, then we need to have that 500, which is the change in the total cost, divided by the 5. So it ends up being 500 divided by 5. So our marginal cost ends up being 100. So just keep that in mind. The book, for the most part, has everything going incrementally, you know, in terms of 1. But you know, I've seen some of the problems on Connect and other places that, you know, doesn't go up by 1. So I just want you guys to be aware of that. Okay, don't get surprised by that. That'll be easy points to lose on the test. Okay, so what do we do? So we're not given the marginal cost. We're given the total cost. We're given the air cons per day. Are we given the marginal revenue? Are we given the marginal revenue in the prompt? Does my marginal revenue change? Does it change over time? No, it stays the same, right? It doesn't matter how many I sell, my marginal revenue is going to be equal to this 120 bucks. Okay? And so we have that. That's going to be constant throughout. Doesn't matter how many air cones I produce that day. That's not influencing the price that I'm getting for these new air conditioning units, right? So we need to expand this table, of course. We need to get our marginal cost calculations going. The marginal cost for the first 100 is 100. Marginal cost for the second bit, right, for the second unit is going to be 50. Marginal cost for the third bit is going to be 70. Marginal cost for the fourth bit is going to be, what is that, 90. Marginal cost for the fifth bit, what's that going to be? That's 95, right? Marginal cost for the sixth bit, looks like it's 105, 140, and lastly, 150. Okay, so you're probably asking yourself, okay, well, we did that. We got the marginal cost now. We've got the marginal revenue. Like, what do I do? You know, and a lot of people do get to this point, and they get kind of stuck. And this is when you have to kind of go back to what's the question asking you, saying, how many AC should I produce to maximize my profit? Well, that maximizing my profit, that's a big indicator, ding, 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 that I'm using my golden rule, right? I'm producing Q star where my marginal revenue is greater than or equal to my marginal cost. Okay, so if you want, you can go ahead and kind of, you can make a new column, but we don't really have, well, I guess we do have that. So let's make a new column. Marginal revenue. What's going to be in this column? 120. Every time. Right? Because it doesn't matter how many we produce every day, we're still getting the same amount. Think about Walmart. Think about, or even like a local coffee shop or something like that, or some place that sells windows or shades or lamps or whatever, right? Like, it doesn't matter how many they sold that day, really. They're getting the same price, and so that, again, that's part of the price taking, right? That's the price taking bit in terms of the perfectly competitive supply, right? This is where chapter 6 deals all with perfectly competitive stuff. Okay, so how are we going to figure out how many to use? Well, we're going to be comparing this marginal revenue with the marginal cost. So do we go ahead, and this is called incremental analysis. The reason why it's called incremental or marginal analysis is because we're literally starting with 0, and we're saying, do we want to build that first one? So it's an analysis that we're taking one by one. That's why it's called marginal or incremental analysis. Okay, so we're saying, do we want to build this first one? And we say the marginal revenue is 120, the marginal cost is 100. If the marginal revenue is greater than the marginal cost, you bet your bottom dollar we want to build that because we're going to end up making a profit on that one, right? What about the second one? 120 greater than 50, 120 greater than 70, right? So all of these are good. This one's good. 120 greater than 95, that's good. 5, yep, we're going to produce 5. Are we going to produce 6? 120 is greater than 105, you bet your butt. We're going to produce 6. Now, what about 7? Is 120 greater than 140? No, 140 is greater than 120, so we are going to stop before we produce that 7th air conditioner. So as a result, the answer here is 6. That's my Q star. Bing, bang, boom. That's all it wanted. Kind of a long way to get to, Q is 6. But like I said, this notion of incremental analysis is going to stick with us through the rest of the class. So if this is something that you're having trouble with, please reach out to me. Please, ask for more videos, ask for more practice or help through, because it's not going to go away. it's gonna be around. We're gonna be doing this in all of the different types of markets, not just the perfectly competitive world. Any questions on that? Oh, I got a chat. 95, 100, I don't know. Okay. All right. Moving on. So let's go ahead and do a graphy one. So we'll do number 4. Chapter 6, number 4. All right, so for a pizza seller whose marginal average and average total cost curves are shown in the accompanying diagram, right? So this is all on page 171. So we've got the price, and this is in dollars. That's terrible dollars per slice. We've got the quantity. Looks like the quail man symbol. That's in slices per day. And this is, generic pizza seller. Not giving any more information on it. So we are given some curves, right? We're given some curves. So the first curve, the probably most important curve, is our average total cost curve, right? So our average total cost curve looks like a big old U. We have an average variable cost curve that starts out high, goes down, and then gets closer and closer and closer to the average total cost curve. I'll explain that in a second. And lastly, we have the most important curve, probably, is the marginal cost curve, which looks like a Nike check sign. And it always goes through, and I did a bad job, it always goes through the bottom. It should have gone through right here, because that's the bottom of the average total cost curve. So I don't know how to fix that. Oh, here. We'll do this. There it is. That'll work. Okay, so why is this average variable cost curve getting closer to the average total cost curve, right? I talked to you guys about, I told you that I would let you know that. So the reason why is because there's actually a third curve on here that we don't actually really talk about a lot, called the average fixed cost curve, right? And the average fixed cost curve, it starts out at a certain value, and then it goes down and it gets closer and closer to zero, right? And that's because of the fact that as we produce more of our quantity, so keep in mind, the average fixed cost, first of all, let's just go back and make sure we understand what a fixed cost is, right? A fixed cost doesn't change, doesn't increase or decrease when the quantity increases or decreases, right? So it's like your rent. It doesn't matter how much, the rent on your factory or something like that, right? It doesn't matter how much you produce that month or how many workers were there or whatever, like you still got to pay that rent, right? But the more that you produce, the more that you're distributing that fixed cost over a bunch of different quantities, right? Because this is just fixed cost divided by quantity. And since this thing doesn't change, right? This stays the same. It's like, $1,500. So when it's over here, it's, $1,500 divided by, 100 or something, right? So it's going to be 150. But then when we're over here and it's 1,000, then 1,500 divided by 1,000 is 1.5, right? So this average fixed cost gets lower and lower and lower, and it approaches zero, right? It has a limit of zero. And so how does this have to do with the closeness of the average total cost and the average variable cost? Well, the average total cost curve, right? What's the definition of our average total cost? Equal to average fixed cost plus average variable cost, right? And so if we do a little bit of algebraic manipulation here, we subtract average fixed cost from each side. We end up with average total cost minus average fixed cost is equal to average variable cost, right? And so this average variable cost, the only reason that it's anything different than the average total cost is because of this average fixed cost, right? If average fixed cost was zero, average total cost would equal average variable cost identical, right? Now it's never going to be zero. It's going to get really, really close to zero, but it's never going to be zero. And so they will never be right on top of each other. But over time, this average variable cost curve gets closer and closer and closer to the average total cost curve. Okay? So now, what is the actual question asking us, right? They're asking us, what is the profit maximizing level of output, and how much profit will this producer earn if the price of the pizza is $2.50 per slice? So we're given a point on the curve. Here, let's use the red pen instead. Given a point on the curve that says 250. We are told that the average total cost curve at that particular 570 slices per day is going to be $1.40. So what is our profit going to be? So we think that the producer is going to be selling the amount where the price equals the marginal cost, right? So oh, I'm on the wrong one. Like, that doesn't make any sense. There we go. So at 570 slices per day, right? That's what they're going to be producing, because the price is 250. And this marginal cost curve, right? We know from that exercise earlier, this marginal cost curve is the supply curve. So at a given price, that's telling us how much is produced. And we know that our profit is going to be, so if this is how much we're selling, and this is how much we're getting for it, right? Then our total revenue is equal to 570 times 250. And then how do we figure out, so our profit, right? We always use pi to represent profit. It's kind of annoying, but just get used to it. Our profit's just the difference between our total revenue and total cost, right? And so what's our total cost? We need to figure out our total cost first. So our total cost, we're actually going to use one of these curves, specifically the average total cost curve, right? What's the other definition of the average total cost curve? Average total cost is equal to total cost over quantity. We multiply both sides by quantity, we end up with total cost equals average total cost times quantity. And that's exactly what we're going to use, because we have the average total cost, 140, we have the quantity, it's 570. So our total cost is going to be 140 times 570. I know that all of this equals 627 when we put it all together. I don't know what these two individual amounts are, but I'm sure you can do them on your own. The other way you can do it, so this is kind of the long form way of doing it. The other way you can do it is this is a fairly common setup here, right? And so the profit, I'll just kind of, I'll go through the motions here. So it's going to be, this is price times the, what is this, quantity. This is price times the average total cost. So these are like elements, right? So we can go ahead and combine them, make it a bit easier for ourselves. So we just end up with 250 times, oh wait, sorry. This is actually quantity. I was like, wait, something's tragically wrong here. This is quantity. Here, let's do this whole thing over again. Start over. So profit is equal to total revenue minus total cost. Total revenue is P times Q. Total cost is ATC times Q. These are the common elements. So we end up doing 570 times 250 minus 140, which is 1.1, right? 570 times 1.1, which gives us the 6.27. 570 plus 57. Questions on that? Either way is totally correct. You can do the shortcut if you want. You can calculate the total revenue and the total cost separately and just subtract them. It doesn't matter to me at all. Whatever works better with your brain. Questions on that one? Okay. Let's do. Okay. Let's do kind of a. Let's do a simple one. That's covering some new material. That's our last one. So we're going to do number 8. Chapter 6. Number 8. And so this says the demand curve and supply curves for the pizza market are shown in the graph below. Oh, price, quantity, pizza market. This is $3. This this is, well, how do we go about calculating the producer's surplus, right? The producer's surplus. So, in a very similar vein to the consumer surplus, right? You have some people, that would be willing to provide, 4 slices of pizza at, $1, right? But they're actually getting $3, right? So this amount here we call the willingness to accept. So remember last time we talked about the willingness to pay. This one is just the flip side of it, the willingness to accept. So here you've got 4 slices of pizza that some people are willing to let go of for $1. But what are they actually getting for it? They're actually getting $3, right? And so this difference between 1 and 3 times 4, so that's 2 times 4, that's $8 of producer surplus there. That's $8 extra that those producers are getting that they didn't necessarily have to get in order to accept that sale. Does that make sense? And there's a similar kind of thing going on here in terms of 8, right? There's going to be 8 slices that are going to be available at $2. And so there's going to be a consumer surplus of 4 times 1 is 4 there, right? And so the way that I'm doing this, it's very blocky, right? I'm missing some of the consumer surplus in these weird little triangle areas and stuff like that, right? And so what we do, just because it's way faster and who wants to actually, you just calculate the area of this whole triangle, right? So you literally just say producer surplus is equal to 1/2 times height. The base of it is 12, right? 1/2 times 12. And then the height of it is 3 minus 0, so 3. So this is 6 times 3 is 18. We have $18 of producer surplus as a result of the existing equilibrium. Does that make sense, everybody?
Yeah.
Awesome. And what I forgot to say was this is all measured in thousands of slices. And and so as a result, it's not just 18.
18,000.
Cool. All right. I think we'll call it there for today. If you guys, feel free to go through. We didn't do questions 6 or 7, and those are very similar to, we didn't do 5, 6, or 7. And those are going to be very similar to question 4 and question 3. So I highly encourage you to do those on your own. If you want to send me the answer and or even your work and have me, let you know by email if that was correct, I'm more than happy to do that. I can also record a video solution and post it up tomorrow or something. So just let me know. Let me know what's helping, what's not. If you like this better than kind of going through the book. I'm pretty open to whatever is the most helpful for you guys. So just let me know and I'll adjust.
Alrighty, thank you.
Of course. Thank you for coming.
Yeah. Have a good day.
All right, you as well. Bye, guys.
Thank you.